Data pipelines are essential in modern data engineering and machine learning workflows. They allow for the seamless flow of data from one process to another, ensuring that each step in the pipeline receives the necessary input to perform its function. In the context of preparing a model for deployment, understanding how to pass data between steps is crucial for maintaining data integrity and ensuring that the model performs as expected in a production environment. The flow of data between steps in a pipeline is critical for several reasons. First, it ensures that each step has the necessary data to perform its operations. Second, it helps maintain data consistency and integrity throughout the pipeline. Finally, it allows for the automation of complex workflows, reducing the need for manual intervention and minimizing the risk of errors. In a machine learning pipeline, this means that data pre-processing, model training, and model evaluation can all be seamlessly integrated. A data pipeline typically consists of several components, each responsible for a specific task. These components include data ingestion, data pre-processing, model training, model evaluation, and model deployment. Each component must be able to pass data to the next step in the pipeline, ensuring that the entire workflow operates smoothly. Understanding how these components interact and how data is passed between them is essential for building efficient and effective data pipelines. Data ingestion is the first step in a data pipeline. It involves collecting data from various sources and preparing it for further processing. This step is crucial because the quality and format of the ingested data can significantly impact the subsequent steps in the pipeline. Data ingestion can involve reading data from databases, APIs, or flat files, and it often includes initial data cleaning and transformation to ensure that the data is in a usable format. Once data is ingested, it must be pre-processed before it can be used for model training. Data preprocessing involves cleaning the data, handling missing values, normalizing or standardizing features, and performing any necessary transformations. This step is essential for ensuring that the data is in a suitable format for training the model. Proper data preprocessing can significantly improve the performance of the model and reduce the risk of overfitting or underfitting. Model training is the process of using the pre-processed data to train a machine learning model. This step involves selecting an appropriate algorithm, tuning hyperparameters, and evaluating the model's performance. The trained model is then used to make predictions on new data. During this step, it is crucial to ensure that the data passed from the pre-processing step is correctly formatted and contains all the necessary features for training the model. After training the model, it is essential to evaluate its performance to ensure that it meets the desired criteria. Model evaluation involves testing the model on a separate validation dataset and calculating various performance metrics, such as accuracy, precision, recall, and F1 score. This step helps identify any issues with the model and provides insights into how it can be improved. Properly passing data between the training and evaluation steps is crucial for obtaining accurate and reliable results. Once the model has been trained and evaluated, it is ready for deployment. Model deployment involves integrating the model into a production environment where it can make predictions on new data. This step requires careful consideration of how data will be passed to the model and how the model's predictions will be used. Ensuring that data is correctly passed between the deployment step and the rest of the pipeline is essential for maintaining the model's performance and reliability. Passing data between steps in a pipeline can present several challenges. These include data format inconsistencies, data loss, and latency issues. Ensuring that data is correctly formatted and consistently passed between steps is crucial for maintaining the integrity of the pipeline. Additionally, handling large volumes of data can introduce latency, which can impact the overall performance of the pipeline. Addressing these challenges requires careful planning and the use of robust data handling techniques. Several techniques can be used to pass data between steps in a pipeline. These include using intermediate storage solutions, such as databases or data lakes, and leveraging in-memory data structures. Each technique has its advantages and disadvantages, and the choice of technique depends on the specific requirements of the pipeline. For example, using a database can provide persistence and reliability, while in-memory data structures can offer faster data access and lower latency. Intermediate storage solutions, such as databases, data lakes, and message queues, can be used to pass data between steps in a pipeline. These solutions provide a way to store data temporarily, ensuring that it is available for the next step in the pipeline. Databases offer structured storage and query capabilities, while data lakes provide a more flexible and scalable solution for storing large volumes of data. Message queues can be used to handle real-time data streams and ensure that data is processed in the correct order. In-memory data structures, such as arrays, lists, and dictionaries, can be used to pass data between steps in a pipeline. These structures offer fast data access and low latency, making them suitable for real-time data processing. However, they may not be suitable for handling large volumes of data or for providing persistence. In-memory data structures are often used in conjunction with other data passing techniques to achieve a balance between performance and reliability. Serialization and deserialization are techniques used to convert data into a format that can be easily passed between steps in a pipeline. Serialization involves converting data into a byte stream, which can be stored or transmitted. Deserialization involves converting the byte stream back into the original data format. These techniques are essential for passing complex data structures between steps and for ensuring that data is correctly interpreted by each component of the pipeline. Ensuring data validation and integrity is crucial when passing data between steps in a pipeline. Data validation involves checking that the data meets specific criteria, such as format, range, and consistency. Data integrity involves ensuring that the data remains accurate and consistent throughout the pipeline. Implementing robust data validation and integrity checks can help prevent errors and ensure that the pipeline operates smoothly. This is especially important in machine learning pipelines, where data quality directly impacts model performance. Error handling and recovery are essential aspects of passing data between steps in a pipeline. Errors can occur at any stage of the pipeline, and it is crucial to have mechanisms in place to detect and handle these errors. This may involve logging errors, retrying failed operations, or implementing fallback procedures. Effective error handling and recovery can help ensure that the pipeline continues to operate smoothly, even in the presence of unexpected issues. Monitoring and logging are critical for maintaining the health and performance of a data pipeline. Monitoring involves tracking various metrics, such as data throughput, latency, and error rates, to ensure that the pipeline is operating as expected. Logging involves recording detailed information about the pipeline's operations, which can be used for debugging and troubleshooting. Implementing robust monitoring and logging practices can help identify issues early and ensure that the pipeline remains reliable and efficient. Security and compliance are important considerations when passing data between steps in a pipeline. This involves ensuring that data is protected from unauthorized access and that the pipeline complies with relevant regulations and standards. Implementing encryption, access controls, and auditing can help protect data and ensure compliance. Additionally, it is important to consider data privacy and ensure that sensitive information is handled appropriately throughout the pipeline. Several best practices can help ensure that data is passed effectively between steps in a pipeline. These include using consistent data formats, implementing robust data validation and integrity checks, and leveraging appropriate data passing techniques. Additionally, it is important to monitor the pipeline's performance and implement effective error handling and recovery mechanisms. Following these best practices can help ensure that the pipeline operates smoothly and that data is passed accurately and efficiently between steps. To illustrate the concepts discussed, let's consider a real-world example of a machine learning pipeline used for fraud detection. The pipeline involves several steps, including data ingestion from transaction logs, data preprocessing to handle missing values and normalize features, model training using a supervised learning algorithm, model evaluation to assess performance, and model deployment to a production environment. By carefully passing data between each step and implementing robust data handling techniques, The pipeline can accurately detect fraudulent transactions and provide valuable insights to the business. Passing data between steps in a pipeline is a critical aspect of preparing a model for deployment. By understanding the various techniques and best practices for data passing, data engineers and machine learning practitioners can build efficient and reliable pipelines. As data pipelines continue to evolve, new technologies and approaches will emerge, offering even more opportunities to optimize data flow and improve pipeline performance. Staying informed about these developments and continuously refining data passing strategies will be essential for success in this field.